All right, students, we're going to look at solubility rules. The whole point of solubility rules is to decide, will an ionic compound be soluble and thus dissolve or stay dissolved, or will it be insoluble and thus remain undissolved, or that is form a precipitate, like mix them and it forms and it slowly sinks to the bottom of your container because it will not dissolve. There are lots of solubility rules. We really do have rules for every possible ionic compound out there, but we're not going to be using all of those in my classes. So these are the rules we're going to be using in my classes, and I just want to show you how we're going to do that. Now, there is one cool little trick to this, okay, and that is to remember this. It only takes one. What do I mean by that? Well, hold on a moment and we're going to do some examples and you will see. Here's what I'm going to do. I'm going to split this ionic compound, the salt, into its cations and anions. I'm going to look them up in the charts here, and then I'm going to figure out if it's soluble or insoluble and what needs to happen. It only takes one piece. That's what I mean by it only takes one, okay? If even one of the two, I have two things, I have a cation, I have an anion. If even one is soluble, it is soluble. And since it only takes one, I am guaranteed to find at least one of the pieces in my charts. All right. Then, if I don't see it in the chart, or they're both insoluble, then we call it insoluble. It only takes one soluble to be found in the chart to make the whole thing soluble. That's all it takes. So we're going to do these examples here. My first example is rubidium thiocyanate. I'm going to split this into cations and anions, and it's real easy. It's Rb plus and CnS minus. And we don't even need to worry about the charges so much, okay? The main part is the Rb and the CnS. So here's what I'm going to do. I'm going to start with Rb since it's first. I'm going to take my finger and I'm going to go down the left column and I'm going to go Rb, 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 looking for Rb. And actually, I don't go very far till I find it. So I found Rb, okay? It says it is always soluble. Now, before I make a conclusion, I want to come over here to the right, see if there's any exceptions. There are no exceptions, so I move my finger back to the left here. Always soluble. So the Rb itself is soluble. So I declare the whole thing soluble because it only takes one part to be soluble. Okay, let's move on to strontium sulfate here. So again, I'm going to split it into Sr. It would be Sr2 plus, and SO4 would be SO4 2 minus. But again, the charges aren't going to matter. I'm not going to trick you with charges. I'm going to start by looking for Sr. So I'm going to take my finger and I'm going down the left column here. I'm going SR, 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 and I don't see it. But that's okay. It only takes one. I should then find an SO4 piece. So I'm going to take my finger and go SO4, SO4, SO4. And in fact, yes, I do see an SO4. Usually it's soluble, okay? But let's check the exceptions. Look at that. Strontium is an exception. If there's an exception, if you hit an exception, you move your finger up, it is insoluble, okay? So SR, I don't know, it's not in the chart, and SrO4 is insoluble, so I'm going to declare this whole thing, if I can spell it, insoluble. I did not find one soluble. It takes one. It takes one soluble. It only takes one, but it takes one soluble for the thing to be found soluble. Okay, let's do this one. NH4, ammonium, and sulfur. Okay, oh, there should have been a little 2 up in there. I will need to add that in at some point. Okay. Anyway, again, I'm not going to trick you. I'm just going to look for NH4, 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 NH4. And actually, I see I don't have to go very far for NH4. Always soluble. There's no exceptions. Move my finger back to it. So the NH4 is soluble. It takes only one piece. I have one piece, so I'm done. I don't even need to look up S. Now, could I find S? That's a possibility. Here we go. S. insoluble except for, and look at what the exceptions, and if I have an exception, I move my finger up, see soluble. So they both say soluble. I only needed to find one piece. I was just showing you how it only takes one really does work. All I need is one piece to be soluble for the whole thing to be soluble. It really, hopefully, is that easy for you. Okay, so let's do gold here. I'm going to have gold, and I'm going to have chlorite. And gold is going to be a +3 and chlorite a -1, and the charges really don't matter. I'm not going to trick you about that. So I go through my list. Oh, you can't see my list. There we go. Go through my list, go AU, 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 AU. I don't see AU. I'm not really surprised. Okay. What about ClO2 minus? So I'm going to go through ClO2 minus, and actually I see it right here. And it's always soluble. There's no exceptions. Slide my finger back. Soluble. It only takes one piece to be soluble. It would help if I could spell this. Soluble. There we go. Only takes one piece to be soluble for the whole thing to be soluble. That's all I need. Okay? So you're guaranteed to find at least one piece in the chart, and it only takes one piece. I need one piece to be soluble for the whole thing to be soluble, but I only need one piece to be soluble for the whole thing to be soluble. Does that mean a lot of these could end up as soluble? Yes, absolutely. There could be a lot of solubilities because it only takes one piece. Okay, let's split this up. I'm going to have Mg. It is going to be a 2+. That really doesn't matter. I have PO4. It is a 3-. That also doesn't matter. Okay, here we go. I'm going to go Mg, 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 Mg. I don't see an Mg. Okay, that's fine. But we should then see the PO4. So I'm going to go PO4, PO4. I see a PO4. And it says it's insoluble except for group 1 metals. Okay, is magnesium a group 1 metal? Catch this. I'm going to say no, it's not, because it's not. It's a group 2, not a group 1 metal. I'm going to slide my finger back. If I say yes to an exception, I slide my finger up, but if I say no, I slide my finger back. Insoluble. I don't know about Mg, and the PO4 is insoluble, so I do not have one. I'm going to just declare the whole thing insoluble. I do not have at least one. Okay. Oh, here's a fun one. How about some tungsten with some chromate? And since chromate's a -2, that technically would make tungsten a +4. It doesn't matter. Okay, we're just going to look at what we have in the chart. WWWWWW, no W's. Okay. Not necessarily surprising to me. I didn't expect to find a tungsten in my little charts here. I just have some of the most common ones, not all of them. How about chromate? We should thus see a chromate because we got to find at least one. And look what I see way down here at the end. I see chromate insoluble except group 1 metals and ammonia. Is tungsten a group 1 metal? No, it is not. So I slide my finger back. Insoluble. Okay. I do not have even one piece soluble, so I'm going to, well, soluble, I keep misspelling it. There we go. Good thing I don't teach English, right? Okay, how about antimony chloride? I have my antimony and my chlorine. I'm not even going to bother showing the charges anymore because for our purposes, it doesn't really matter. I'm looking just for Sb, 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 Sb. I don't see it. What about Cl, 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 Cl? I do see it right here. Usually soluble except for. There's only 3 exceptions here. Is Sb one of these 3? The answer is no, so I slide my finger back to the left. Again, if you're on the exception and you say yes, you go up. If you say no, you go back. Soluble. So I'm going to go with soluble because it only takes one piece. That chlorine is soluble. I'm going to go with soluble. Okay. What about tin oxide? Okay, so I have some tin and I have some oxygen. And yes, it's tin 4, and yes, it's oxygen -2, but at this point, I think you'll realize it really doesn't matter for our work. So just looking for an SN, 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 SN. I don't see an SN. I didn't really expect to. How about O? I better find one piece. I'm looking for just an O, an oxide, an O -2, right there. Insoluble. Okay, now let's check the exceptions, and I'm looking for SN. Is that a group 1 metal? No. Is it one of these three? No. When I say no, I slide my finger back. Insoluble. So tin oxide is going to be declared insoluble. I do not have at least one soluble. Okay. What about my lithium here? Let's do some lithium, and again I have chromate. Okay, so here I go, going down the list, looking for Li, 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 Li. Did I see an Li? I actually did, right there. Always soluble, no exception. Slide your finger back. Always soluble. Hey, I'm done. I have one piece, the Li piece is soluble. I'm going to declare the whole thing to be soluble. That easy. Okay. So moving on. And I know you're like, hey, you're going really fast. It's okay. It really does go this quickly. You just look for you figure out what parts to look for. You look for the parts and move your finger. It's that easy. All right, so let's do some Hg. I'm going to look for Hg, 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 Hg. I don't see Hg. Okay, well, that's fine. Let's look for Cl. Cl, 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 Cl. Okay, I did find Cl. And it says it's usually soluble, and now I check for exceptions. Ooh. Now, catch this. I'm not trying to trick you. This says Hg2, and down here I have Hg2, so it is the same. So what do I do when I do have an exception? I drag my finger up for yes, down, left for no. Insoluble. I did not find Hg, and I found Cl to be insoluble, so I'm going to declare the whole thing insoluble. Okay? CaO. Well, hopefully you realize that breaks into Ca and O. Let's look for some Ca. Ca, 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 Ca. Oh, you can't see my list. There we go. Ca, Ca, Ca. Nope, don't see it, but I do see an O. Insoluble except for. Now here's the thing. Do I see Ca? I do. What do I do when I say yes, I have an exception? I go up. Soluble. Okay, one soluble, the whole thing's soluble. That easy. It only takes one. It only takes one soluble for the whole thing to be soluble. So there we go. All right, two left, and then you're on your own. And hopefully this quick little video has made it very clear this is not difficult. Just take your time. You got to split it well and look for your pieces. Okay, and I'm not going to trick you. I'm not going to have because manganese can have 4 different charges. I'm not going to have in my chart a manganese with 4 different charges. If I have a manganese in the chart, that's the manganese you're going to use. But I look and I don't have a manganese, so we're even good there. I do have an SO4. I better find an SO4. Let's find an SO4. Oh, I found an SO4. And it says usually soluble except for, do I see an Mg in this list? I do not. What do I do when I say no? I come back. Soluble. So if even one piece is soluble, the whole thing is soluble. Nice and easy. Okay, it only takes one. That's our phrase. It only takes one. That reminds you, you only need one piece in the chart, and that one piece is all it takes to be soluble, for the whole thing to be soluble. Pretty handy. Okay, last one. I've got copper. It is technically copper 1. Again, I'm not going to trick you with that. Has to be copper 1 because sulfur is a -2, and it takes 2 coppers to zero that out. Anyway, let's look for copper. Cu, 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 Cu. I don't see copper. Okay, I better find S then. S, 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 S. Ooh, I do see S right there. And it says it's usually insoluble. And now I'm looking for copper. Is copper group 1 metal? No, it's not. Is copper group 2 metal? No, it's not. Is copper ammonia? No, it's not. What do I do when I say no? I go back to the left again. Yes is up. No is back to the left. Insoluble. I have not found even one soluble, so I'm going to declare this whole thing insoluble. I did not find one. It only takes one, but I did not find one. If I don't find one, it's insoluble. Hopefully that easy. So I really hope this helps you understand how really easy it is to quickly and efficiently use a solubility rules table. And these come in all sorts of shapes and sizes, and some of them have literally every element on the periodic table in them, because we do have those rules. but you don't necessarily need them for this class. So these are the charts we're going to be using for our class and for the test. And this is the chart you're going to want to use for your homework and so that you're ready to use it for the test. All right, you have practice to do. Get to it and good luck.